Good morning students. Now we can see properties of Laplace transform. So there are the properties are here. First one, linearity property, time shifting property, shifting in the S domain or frequency shifting, time scaling, conjugation, convolution, differentiation in the time domain, differentiation in the frequency domain or S domain, integration in the time domain, initial value theorem and final value theorem. Okay, so here the all the properties we are going to see in detail with their proofs. Here the statements are given here. First, if you take any x of t, this is time domain signal. The signal can be represented in the Laplace as x of s. Then x1 of t means x1 of s. x2 of t is x2 of s. Okay, if it is a linearity property, a into x1 of t plus b into x2 of t, this Laplace transform of this is a x1 of s plus b x2 of s. So this is the statement for the linearity property. Okay, now we will see in detail of each and every property. The linearity property, here the statement is you have and the proof also we have. Let Laplace transform of x1 of t can be written x1 of s. We all know that. And you take another signal L x2 of t is equal to x2 of s. Okay, two signals we are considered here. x1 of t, x2 of t, their Laplace transform is x1 of s, x2 of s. Then Laplace transform of a1 x1 of t plus a2 x2 of t is equal to a1 x1 of s plus a2 x2 of s. So this is the statement of the linearity problem. Already we know that the linearity is nothing but superposition principle. So that is given here. Now we can see the proof. We all know that Laplace transform formula, that is L into Laplace transform of x of t is equal to x of s integration minus infinity to plus infinity x of t e power minus st dt. This is Laplace transform formula. If x of s, this is the definition, means if you have x1 of s is equal to, here 1 means x1. Similarly, x2 of s can be written like this. Now we come to the proof part. Laplace transform of a1 x1 of t plus a2 x2 of t. The whole thing you can have it as a signal that can be given to the part. Okay. Now integrated minus infinity to plus infinity a1. This is x1 of t e power minus st dt plus integration minus infinity to plus infinity a2 x2 of t e power minus st. From these two, you bring out the constant a1. The remaining term you will get it here. Similarly, from the second term, you bring out a2. The remaining term you have it this one. So a1 you have as it is. The remaining part as we have written like this. The x1 of t e power minus st dt is x1 of s. The whole thing I can replace by x1. Similarly a2 into x2 of s. So hence the property is proved. Next property is time shifting. Let Laplace transform of x of t is equal to x of s. Then Laplace transform of x of t minus t naught. This is time sheet. We all know that is equal to e power minus s t naught x of s. So this we have to prove. So the proof is, first you write down the definition of the Laplace transform is given here. Laplace transform of x of t minus t naught. We have to do it for the t minus t naught. T naught is the time shift. Now, wherever the x of t is present, that can be replaced by t minus t naught. Okay. Now, as we have, let this t minus t naught can be taken as a other variable as a tau. Now, t is equal to tau plus t naught. Now, you differentiate with respect to t. So, dt is equal to t naught. The t naught is a constant. It becomes 0 while doing the differentiation. Now, in this formula, the t minus t naught can be replaced by, because we have assumed as tau, you replace by tau, e power minus s, the t can be replaced tau by t naught. Okay, tau plus t naught into the d tau can be replaced by d tau. dt can be replaced by d tau. Now, you simplify this equation. Now, you will get the final answer. Now, from this, e power minus s t naught, you bring it out. The remaining term can be written as x of s. Okay. Now, if the input is x of t minus t naught, the response is e power minus s t naught x of s. Hence, the property is proved. The next property is frequency shifting. Let Laplace transform of x of t can be represented as x of s. Then Laplace transform of e power plus or minus at x of t is equal to x of s plus or minus a. So, we have to do proof this. Now, Laplace transform of x of t. Write down the definition first. All of you know the Laplace transform formula. Then, instead of x of t, we have to substitute the frequency shifting as e power plus or minus at x of t. That you substitute it here wherever x of t present in the formula. Now, combined both the exponential term as it's shown it here, x of t e power minus s plus or minus a into t dt. Okay. Now, the final answer is, if there is a s, you will get s in the answer. If the exponential term you have s plus or minus a, the same it represents in the transform x of s plus or minus a. The next property is time scaling. Time scaling property, that is x of a into t. Time scaling, all of you know that very well how to do the time scaling. X of at equal, the Laplace transform is 1 divided by modulus a x of s plus s by a. We have to do the proof. First, you write down the Laplace transform formula. Here, x of t can be replaced by x of at because we have to find the Laplace transform of at. Now, you consider this at equal to another variable by tau. Now, we need what is t? T equal to tau by a. Now, you differentiate with respect to t, d tau by a. Now, you substitute all the assumed variable in the equation. Integral minus infinite to plus infinite, the at can be written as a tau. E power minus s, instead of t, we can have tau by a, d tau by a. The dt can be replaced by d tau by a. Now, here 1 by a is a constant, you bring it out. The remaining term you have integral minus infinite to plus infinite x of tau e power minus s by a tau d tau. Now, the whole thing can be, the red circled can be written as x of s by a. Generally, you know that in the Laplace transform equation, the exponential term if s means it is x of s. Similarly, here s by a can be replaced by x of s by a. For example, here we consider the a is positive, you will get. If a is negative, this Laplace transform of x of minus at equal to minus 1 by a x of s by a. So combining both, we can have this modulation. So x of plus or minus at can be written as 1 by modulus of a x of s by a. The next property is conjugation property. Conjugation property is x conjugate of t. If you take a Laplace, you should get x conjugate of s conjugate. So this is the statement of the conjugation. Now we can take Laplace transform. So you all know that the Laplace transform formula, instead of x of t, here what is our input signal? X star of t. So you substitute instead of x of t, x star of t. Here x star is nothing but the star denotes the conjugate. Now we want to replace the conjugate from the above equation. What you have to do to replace the conjugate, x of t e power minus this n's conjugate, because s is the complex variable, dt the whole conjugate. So if I take the conjugate inside, this get cancelled, you will get into the x conjugate. Okay, so now you just look at the formula. Here I told you what are all the changes you have it in the formula, that you will get into it. Now x of s conjugate, the exponential term is s conjugate, that you can write it. Then overall you have the conjugate. Okay, finally x conjugate and s conjugate. So this is the proof of conjugate. The next important property is convolution property. You all know that let x1 of t, okay, the Laplace transform is x1 of s, x2 of t, x2 of s. Now the convolution symbol is this one, x1 of t convoluted with the x2 of t is equal to x1 of s, x2 of s. Convolution of two time domain signal is equal to product of two frequency domain signal. Okay, that is the statement of convolution. Now we all know that the convolution formula, x1 of t convoluted with the x2 of t is equal to, this is the formula for the convolution. Let us see the proof part. x1 of s, you all know that you write the definition. Similarly for the x2 of 2. Laplace transform of x1 of t convoluted x2 of t is equal to integration. So the whole x of t can be replaced by this convolution, x1 of t convoluted x2 of t e power minus st into dt. Now this convolution x1 of t convoluted x2 of t can be replaced by the formula. So this part can be replaced by the convolution formula like this. So what we are going to do? Integral minus infinity to plus infinity x1 of tau x2 of t minus tau into d tau. Interchange the order of the integration, because here you have two integrations. Interchange the order of integrations to simplify the above equation. Now one integration minus infinity to plus infinity x1 of tau, then another integration x2 of t minus tau e power minus st dt. You take, this is one group, now d tau. Now already we have discussed the time shifting property. As we know the time shifting property, so the above part can be, the red color rounded thing can be replaced by e power minus s tau x2 of s. So the time, as per the time shifting property, this red color rounded term can be written as e power minus s tau x2 of s. The next one, rearrange the integration again, because x2 of s, you bring it out. Integral minus infinite to plus infinite x1 of tau e power minus s tau d tau. Now this part can be written x1 of s, because this is similar, same as the Laplace transform formula. Here x1, that can be written as x1 of s. So hence the property is proved. Next property is differentiation in time domain. The first part you know at. Then dx of t. This is time domain signal. Differentiate the time domain signal with respect to t. If you take the Laplace transform, it gives s into x of s. Now we can see the proof part. So all of you know the inverse Laplace transform formula we have written here. X of t equal to 1 by 2 pi j integral sigma minus j infinity to sigma plus j infinity x of s e power st ds. This is inverse Laplace transform. The above equation can be differentiated with respect to t on both sides. So you differentiate the above equation with respect to t by both sides. So if I do the left side, you will get dx of t by dt. Here you will get the integration part same. Only the integration we have to do it for e power st. If I do the integration, I will get s x of s e power st into ds. So if you compare the equations left side and right side, you will get the input as s x of s here. This is dx of t by dt. So this is the property what we have to prove. Hence the property is proved. The next property is differentiation in frequency domain. So this is general statement. Let x of t, the Laplace transform, can be denoted by x of s. Then minus t x of t, this is the input. If you take the Laplace transform, dx of s by ds. This is the statement. Okay, this we have to prove. You all know that Laplace transform formula, it is written here. So this is Laplace transform formula. Okay. Differentiating the above equation both sides with respect to s. So if you do the differentiation, dx of s by ds is equal to, with respect to s we have to do it. Now minus t x of t e power minus st dt. From, if you look at the equation, you see the right hand side and the left hand side. Okay, you compare it. Comparing the equations, dx of s by ds, we have to get minus tx of t. This is the statement of differentiation in frequency domain. Hence the property is proved.